Today we will learn the derivatives of the basic trigonometric functions, and we will prove how to derive one function using the first principles. Once you understand how to derive one function, the rest will become easier. Now we are going to find the derivative of f of x is equal to sin x using first principles. So here we have f of x equals sin x as our first equation, and as like we learned before, our second equation will be f of x plus delta x is equal to sin x plus delta x, where delta x is an increment of x. When we subtract equation 1 from equation 2, we get f of x plus delta x minus f of x is equal to sin x plus delta x minus sin x. Now we need to use some of our trigonometric knowledge. You have learnt these formulas in trigonometry before. If you look at this table, here you can see that sin c minus sin d is equal to 2 into cos c plus d over 2 into sin c minus d over 2. So we can use this formula in this equation here. So that will give us f of x plus delta x minus f of x is equal to 2 into cos c plus d over 2, that is x plus delta x plus x divided by 2 multiplied by sin c minus d over 2, that is x plus delta x minus x divided by 2. So when we simplify this, we get 2 into cos 2x plus delta x over 2 into sin delta x over 2, since x here gets cancelled off. Now we divide both sides by delta x. So this will give us f of x plus delta x minus f of x divided by delta x is equal to 2 into cos 2x plus delta x divided by 2 into sin delta x divided by 2 whole thing divided by delta x. Then what we do is we apply the limits as usual. We apply limit as delta x tends to 0 to both sides. So we have learnt in our previous chapter before that we can apply limits separately. So this can be written as 2 into limit of cos 2x plus delta x over 2 as delta x tends to 0 multiplied by limit of sin delta x over 2 divided by delta x as delta x tends to 0. You will know in a while why I divided this sin function by delta x and not this cos function. So here we can apply direct substitution. So this part will be dy by dx or f prime x. So that will be equal to 2 into, when delta x tends to 0, this becomes cos 2x over 2, giving us cos x. Now for this part, if you remember in limits, we learned this formula. Limit of sin x over x as x tends to 0 is equal to 1. We can use this formula here. So but we have to make a few modifications. What we have for now is limit of sin delta x over 2 divided by delta x. So basically the part here should also be the denominator here. So we divide this denominator by 2. So we can't just divide by 2. What we can do is we divide the denominator also by 2 and divide the numerator also by 2. So that way it is balanced. So we have limit of sin delta x over 2 divided by delta x over 2. Now this part is done according to our formula. We can change delta x to delta x over 2 because as delta x tends to 0, delta x over 2 will also tend to 0. So we can replace delta x with delta x over 2. So now we have this part in according to our formula. So this will be equal to 1. That will give us 2 into cos x into 1 into 1 over 2. So this 2 and this 2 cancels off, giving us f prime x is equal to cos x. So the derivative of sine x is equal to cos x. These derivatives of trigonometric functions are very important, and you will be using this throughout calculus and also chapters outside calculus. Similarly, we can find the derivatives of other trigonometric functions. Here is a summary of the derivatives of all the basic trigonometric functions that you will be using. So the derivative of cos x is minus sine x. The derivative of tan x is sec squared x. So the derivative of cos x is minus cot x into cosec x. The derivative of sec x is sec x tan x. The derivative of cot x is minus cosec squared x. You can try to prove these derivatives using first principles, just like how I proved them now. You will need to use your knowledge in trigonometry here. If you have any issues in proving these functions, feel free to mention them in the comments below. We are always ready to help you. Until we meet again, take care.